Hi, I'm Steve Hoover. I'm the founder of a startup called Redwood EDA. Welcome to my workspace. Welcome to the workshop. I'm excited to be doing this workshop with Kunal and with you guys because I've been working really hard these past several years to introduce the silicon industry to better methodology supported by better tools. I believe with the right tools, silicon design, circuit design can be much more accessible, can be easier to do, can be much more productive in industry, and can be a whole lot of fun. And I do hope you have a lot of fun in this workshop. I was a circuit designer for companies like Intel for almost 20 years. And in that time, I learned a lot about how silicon design was done. And more importantly, I learned a lot about how it should be done. And that's what you're going to get to experience today. In this workshop, you'll learn the methodology and the tools. You'll have the opportunity to design from the ground up your own pipelined RISC-V CPU core. These skills are generally taught over multiple college courses, and you'll get the chance to do them all in the remaining time in this workshop. I commend you for your willingness to not only teach yourselves a new skill with circuit design, but to teach yourself skills that put you ahead of the curve. So with that, let me jump into the slides and we'll get started. So, building your very own RISC-V core. That's the focus for the remainder of the workshop. This is how the days are broken down. So today, the focus is going to be on learning digital logic. Rather than learning this on whiteboard and textbook, the way most digital logic courses work, you're going to be able to jump right into the MakerChip online IDE platform. And you're going to use transaction level Verilog, which is a language extension to Verilog. And even though it's a language extension, in a lot of ways, it's simplifying Verilog. So you'll learn about TL Verilog, you'll learn the MakerChip platform, you'll learn about digital logic, and you'll be coding from the very start. After you learn the basic skills on day 3, in day 4, the focus is going to be on RISC-V. So you're going to start by coding up a RISC-V CPU. I'll walk you through it. This CPU at this point will support a subset of the instruction set architecture, the subset necessary to execute a test program. And in fact, that test program will be the program that you wrote with Kunal and ran through the compilation tools and assembler. On day 5, and we might get to some of this in day 4, but for the most part on day 5, the focus will be on taking that core that you've written and pipelining it. And we'll do a couple variations of how we pipeline that CPU core and completing that CPU core so that it supports the full RISC-V instruction set architecture.
Today in particular, we'll focus on digital logic. So starting off with the fundamental building blocks, logic gates. And very quickly, we'll move into the MakerChip platform. You'll be able to code up logic gates in TL Verilog. You'll find the syntax is very straightforward. We'll see the logic gates run in simulation, and we'll see their behavior. We'll construct more interesting combinational logic out of these logic gates. And then we'll move from combinational logic on to sequential logic, where we're introducing a clock into our design. And from there, trying to run our design at a high frequency. So getting high performance by running at a high frequency clock. And this requires pipelining our logic. So we'll talk about pipelines. And then we'll start coding a few examples that contain state. And based on the state, that'll impact the behavior of our model. So our model can change over time based on its state. So as you go through the labs and through the workshop, we've got some resources available to help you in case you get stuck. And you can go ahead and open this link right now. I'll do the same, so let me exit out of the presentation. So this is just my GitHub repository. And I'll just go to this part of the URL to my GitHub repository itself, which you can just type in. And if you go to my repositories and look for this Myth workshop, and as we're going through this workshop, we'll be opening up a number of websites. You'll be working in MakerChip in several different sessions. So expect to have several windows that you're keeping open. This will be your first, and we'll come back to this page in a little bit after you've gotten your feet wet. But just to get started, I want to explain that we have two servers running MakerChip that we've set up specifically for this workshop. For one, we set these up because we have a lot of students working on these labs simultaneously, and we should get a little better performance out of these servers than just off of the main makerchip.com server. Also, I've enabled a feature specifically for this workshop, a feature that's not yet available on the public, the general, just makerchip.com. And we'll talk about that one too. But just to get started, I want you to be aware that these two servers are available at myth1.makerchip.com and myth2.makerchip.com. We're going to start out, you can just use makerchip.com for the first couple labs, but in case you have performance issues there, you can jump over to these two. All right, so back to the slides for now.